first, jot those down. These will be the last formulas we put on this tab.
The bottom two? Or all?
All
Four.
four.
I don't know.
Do the exact same things that we did yesterday, just more formulas. So if I said exact value, that means not with a decimal, using radicals. So we have to rewrite it in terms of angles that we know. So how could I get a negative 15 degrees?
45 and 30.
30 minus 45.
Mm-hmm. So then we use our sign difference formula. So the subtraction, it's not treating it like a negative 45. That's what tells me I'm using the sign of A minus B. So sine of the first cosine of the second minus cosine of the first sine of the second. What is the sine of 30 degrees? What is the cosine of 45?
Radical 2 over 2.
Minus, what's the cosine of 30?
Radical 3 over 2.
And the sine of 45?
Radical 2 over 2.
So when you multiply, you just go straight across. 1 times the square root of 2 is the square root of 2. 2 times 2 is 4. Square root of 3 times the square root of 2. Since they're both under radical, you can multiply them together. It gives you radical 6 over 4.
Oh, that's crazy.
Almost like it's the same.
Twice less.
Well, if you think about it, all of these are coming from the same reference angles. 30, 45, and 60. The only numbers we're getting out are 1/2, radical 2 over 2, and radical 3 over 2. So it's going to be very repetitive. You also think about it, I'm only giving you angles you can find, and we know that if they have the same reference angle, it's equal to the same value. So that's why we're getting the same answers, just different variations of the plus and minus.
But
Because
hey,
in
you know, if
quadrants.
you get like a radical 4 or something, you know
Maybe
you
you
get
made
it
a
wrong.
mistake. All right. Is that one okay? What it said,
About turn it into degrees.
tangent of 13 pi over 12. You are welcome to keep it in radians. However, I think most of us will probably struggle a little bit trying to find what adds or subtracts to 13 pi over 12. So to convert, we multiply by 180 over pi. And what 13 over 12 times 180 is what?
195.
Right, so we need two angles from our unit circle that add or subtract to 195.
225 minus 30.
And there are different options. You could have done, let's see, 45 plus 150. That would work as well.
135 minus or plus 60.
135 plus 60. So lots of different options. All right, so our formula. Tangent of the first minus, because we had the subtraction, tangent of the second divided by 1 plus tangent of the first times tangent of the second.
Remember that thing about how I wasn't going to write it down wrong?
Mm-hmm.
I'm going to write it down.
Might have.
Just a little bit.
All right. Let's think about 225 for a second. What quadrant is that?
3,
Reference angle?
45.
In quadrant 3, is tangent positive or negative? Positive, and the tangent of 45?
1.
Minus, what is the tangent of 30? Over 1 plus tangent of 225 is 1, tangent of 30 radical 3 over 2. So we have 1 minus radical 3 over 3 over 1 plus. radical 3 over 3. Okay, there's a lot wrong with this right now. What's one big problem?
There's a fraction in the denominator.
Fraction, and a radical in the denominator are the two big things. So we have to do some simplifying here. I am going to be a little bit lenient. I am not going to make you get the radical off the denominator unless you really want to. Just because we've done that enough, I know that you can. But I do want to get rid of the fraction and a fraction. So
Times 3.
if you were going to get rid of the radical, you would do the whole conjugate. If all you're getting rid of is the fraction, you could just get by with multiplying by 3 because that's our denominator. And if I do that, I get 3 minus radical 3.
It hurts to not.
So, I would accept this for an answer. If you wanted to go ahead and finish it, what would you multiply by now?
3 minus radical 3.
So you can leave it like that. Know that if you're looking in the book, it will rationalize, but these get a little ugly. So on the top you would get 9 minus 6 radical 3 plus 3. On the bottom we get 9 minus 3. So 12 minus 6 radical 3 over 6, or
2 minus radical 3.
Looks a lot nicer.
it's a lot nicer if you take the steps to go ahead and rationalize. I would accept either. I'm not going to be super picky, but I don't want you to leave it with a fraction and a fraction. That's an easy fix to get rid of. The tangent ones, because there's so many different options, if you don't rationalize all the way, you might have an equivalent answer that looks different, especially if you're trying to check your answer with a partner or the back of the book. You can always see if they're the same by putting them in your calculator and seeing if you get the same decimal equivalent back as well. Or if you're really unsure, just go ahead and rationalize. It's not that much more work. All right, is that one okay? C. Tangent of 100 degrees minus the tangent of 70 degrees over 1 plus tangent of 100 tangent of 70.
We gotta do the formula backwards.
Yeah. So which formula is that?
Subtraction tangent.
So it's tangent of A minus B. So 100 minus 70. Or 30 degrees, and the tangent of 30 is?
Or square root of 3 over 3.
Tangent's the bottom over that top.
Radical the top over radical the bottom. So square root of 1 over the square root of 3. And you have to get the radical off the bottom.
Oh.
Alright. How were these? You guys need to try a couple? I have another slide with examples like this. Do we need them or do you guys feel okay?
On the root.
That's not the one I wanted. Let's go to this one.
Oh no.
Oh, it's not.
Forgot about this part yesterday.
So again, here I'm really just asking you to simplify this as much as we can. So the first sine of 120 plus theta, what would I do?
Sine 120 cosine theta.
The sine of A plus B formula. Sine of the first, cosine of the second, plus cosine of the first, sine of the second. Alright, for 120, what quadrant is that?
2.
Reference angle? 180 minus 120 is 60. Okay, and quadrant 2 is sine positive or negative. What's the sine of 60?
Radical 3 over 2.
Quadrant 2 is cosine positive or negative.
Negative.
And what is the cosine of 60?
One negative whatever. 2.
Is there anything we can do here?
Not really.
Not really. I mean, you can write it as just a radical 3 over 2 cosine theta minus 1 half sine theta. But that's really all. We can't simplify beyond this. So we're just simplifying as much as we can with our formulas.
Would you take the one above it, or would you rather this just?
I would take either.
I'm really excited about how this came.
Want to know the
I do.
We're doing good on that.
You have to. Do we need to turn this into degrees?
We could, but we don't have to on this.
Okay.
So we would be using the tangent sum formula here. So that is tangent of the first is tangent of the second over what?
1 minus tangent of the first times tangent of the second.
Do you do anything there?
Yeah, we can. Yeah, 3 pi is going around 0, 1, or 1, 2, 3 pi is right here. It's the same as pi. So if we think this is like, and so what is tangent? 0. So we get tangent of theta on top. On the bottom, you get 1 minus 0, which is just 1. So tangent theta.
Or you can separate over 1.
That's fine. Alright. Why don't you guys try this one?
Oh, yeah, okay.
Sine difference formula. So sine of the first, cosine of the second, minus cosine of the first, sine of the second. So if you're thinking 270 is here, that's 0, negative 1. So cosine of 270 is,
0.
I wrote, sine of 270 is negative 1. So we get 0 minus a negative cosine, which is just positive cosine theta. Is that okay?
Yes.
All right. Then, do we need any more like that? Let's do a proof or two.
Oh my.
Isn't that pretty?
Mm-hmm. Did you make it yourself?
Maybe.
It's so pretty. Oh, I looked up. I don't know where to start.
It is not real pretty. Which side would you want to box in, maybe? I think I would box in the right, only because if you look at these angles, we have things being added or subtracted, which means we could use an identity.
Yeah.
So I would box this in. Even though it's not overly beautiful itself, maybe we'll get somewhere. So now we use our formulas. Tangent of the first tangent of the second over 1 minus tangent of the first, tangent of the second. And this one, same thing, except we're flipping the signs. Tangent of the first minus tangent of the second for 1 plus tangent of the first, tangent of the second.
Can we just multiply the one of them by a negative?
That'll change both signs. Okay, what is the tangent of pi over 4?
45. Or, sorry, a 1.
So 1 plus tangent of t over 1 minus 1 times tangent of t is tangent of t.
Oh, that's a t, not a 1. Okay. I wrote 1 wrong.
Our variable is t this time.
Yeah.
Probably not the ideal choice, but it works.
Wait, so we took pi over 4 and then we did tangent of pi over 4, right?
Mhm.
That's where our 1 came from. Everything looks like t's.
I keep looking like I wrote int over and over and over.
No, we're gonna have to multiply the bottom over.
Gotta do the conjugates.
What do we need to get here?
That's easy.
Common mama mela.
Common denominator. So, I'm going to take the first one times 1 plus tangent of t on top and bottom. And the second one has 1 plus on the bottom, so it gets 1 minus.
Should we distribute? Is it worth foiling?
Yes. So if we flip, we get 1 plus 2 tangent of t plus tangent squared t. And the bottom that's 1 minus tangent squared t. This one is 1 minus 2 tangent t tangent squared t. We're actually close. What can we do now?
Take out the, we'll add them and then take out the common denominator.
We put them together. When I do that, these will cancel. So we have 2 plus 2 tangent squared t over 1 minus tangent squared t. So what can we take out on top?
The tangent.
And what is 1 plus tangent squared?
Secant.
And I think that's what we wanted. Any questions there? Okay, so those are all the examples that I have. So I'll go ahead and give you the homework and you can get started. Those of you that want to see the proof, do you want me to do it now or after you've worked on homework for a little bit?
I've worked on homework while you were